This is Joe Maciars from A Tutoring Enterprises. Today I want to talk about graphing polynomial functions. Specifically, I want to talk about the degree of the polynomial and the zeros of a polynomial function. And we're going to really look at some very basic functions. We just want to sort of get an idea of how degree plays in what the zero looks like. So let's go over to the graphing calculator and start to get an idea. So on the last video we were talking about the idea that this was one of our more basic rational polynomials, and we needed to learn some basic ideas about the polynomials in order to understand rational polynomials. So let's go ahead and just basically get rid of all of this stuff, and we're going to just start from scratch. So we're going to start with n equal to 1. And this is really going to be very basic. We're going to do y equals x to the n. That's basically it. Now right now n is equal to 1, so we'll end up with y equals x, which is just a straight line. So let's go ahead and color the line. And we'll make it that particular color. Okay. Now, there's some points that I want to kind of highlight, so I'm going to add a few points to our discussion. You might remember we go to a parametric equation for this, and we get rid of the parametric stuff. And I like to put little spaces in there so I can see what's going on. And some of the points we're going to highlight are 0, 0. And let me copy that, get a new equation, paste that in, and we're going to want to look at 1, 1. And let's see, I think I'm going to do something kind of fancy here. I want to use n to help me. Now, what I'm going to do is I'm going to let the x value be negative 1. And the y value I'm going to let be negative 1. Now I want to show you what happens though when I let n be the exponent on the second negative 1. Well, not too much because n is 1, so negative 1 to the 1 will be negative 1. Alright, what will happen though is when n is 2, and we are going to change n along the way, that's going to be our parameter that we're going to animate. Let's imagine that n is 2. If we had 2, then negative 1 squared would be negative 1 times negative 1 and would become positive 1. Alright, so just before we go to animate that, I'm going to go ahead and clean up these points a little bit. You might remember that I like to make the insides the same color and make them just a little bit smaller. And so there we go. Alright. Well, let's go see what happens. We're going to look at very specific n's. We're going to look at n's that are whole numbers. That means either 0, 1, 2, 3, and so on. In fact, let's see, do I even want to look at... Yeah, I guess I'll look at 0. I mean, it's not a huge deal. Let's take a minimum value of 0. Let's take a maximum value of 11. Yeah, I think 11 will do it. And then our steps are going to be 12. And you'll see that that gives us steps of 1, which is exactly what we want. All right. So I'm actually going to slow this one down a little bit. And I don't know if that's going to be slow enough, but we may come back and adjust that. All right, but I'm just going to play this, and I just want you to take a look and notice what's happening to the green line and what's happening to the points. Take a little gander. Okay, well, a couple of things that we can see right off the bat as this is going is clearly that point, 1, 1, is not changing at all. Every one of these curves goes through that point. It's effectively pinned at that point, and it's also pinned right there at 0, 0. Now, it's kind of pinned here or here for the left side. But we want to start to figure out what it is that's going on here. I'm going to do something now a little different than what we're just seeing right here. Let's go ahead and pause this. And let me go ahead and change this to 21. I think that'll do it. No, I guess 22 is what I want. Yes. And that's going to allow me to go by 2's. Now, let's take a look at what happens when I do that and play. Well, now we don't have this point going back and forth. It is now effectively pinned at -1, 1. And what's true about these ends? Well, all of the ends are even. And, well, this is a basic polynomial degree function. It's the main term of a polynomial. For example, if, let's go ahead and pause this for a moment. So if n is 16, then this is x to the 16th, and this would be a 16th degree polynomial. I've also heard the word order used with this. That's also used in a different way, but I'm going to stick with degree here because most of the textbooks seem to have degree, and I'm not going to try to distinguish between degree and order. But in any case, degree right now, the degree of this is 16, and as the degree decreases, first of all, we can see that this is effectively becoming less box-like. It's becoming more rounded, and maybe we shouldn't really consider n equals 0 because n equals 0 is not going through this particular point. But for the rest of them, they're all going through 0, 0. And that's important because this is what we're going to call a 0 of the function. Now, even as I make n really big, n equal 22 in this case, you might be shocked to know that despite the fact that this looks very flat, there's only one single point on this green curve that's actually touching the x-axis, and that's the point 0, 0. If you put in any other point, any other x value, I mean, think about it, put in some other, like, well, what is this? Let's put in 1/2, just a simple 1/2. Now, this is 1/2 to the 22nd. Now, you might say, well, yeah, okay, that's really, really close to 0. Yes, it is, but it's not 0 is the point. It's a little bit bigger than 0. In fact, it can't be 0. Any x value that's not 0 is going to be a little bit above 0. Now, because of the particular scale that we're at, we really can't see any space between the green line and the x-axis at any of those points. We could zoom in and see that. I'm not going to do that. I'm going to let you do that. That's the type of thing that's would be a good exploration for you as a student. But I'm simply going to tell you that's the only point that's on the x-axis. And if we were going to ask, if I was going to ask you to describe this to, let's say, a second grader, what would you say, other than the point 0, other than n equals 0, what would you say is true about all these graphs? Well, of course, they're going through the points 1, 1 and -1, 1 and 0, 0. That's true. But how would you describe the curve itself? Well, you might talk about the roundedness and the box structure. We talked a little bit about that. But if I was going to talk about this point and wanted to talk about it, which I do, I would talk about it as just touching the x-axis. It's the only point that just touches the x-axis. That is, the graph itself does not actually pass through the x-axis. It just comes down and touches it. That's it. All right. That being said, let's go take a look now at making this 1 through 23. And we should again get spacing of 2's here. And if we now play this, well, we get sort of a similar type of behavior, except that this point is now pinned at -1, -1. So we have this point, the 0, 0, and the 1, 1. Clearly, it becomes more box-like as n increases. But as far as the 0 is concerned, the place where the entire polynomial is equal to 0, that again still only occurs at x equals 0. The same thing that was true about the right-hand side is true, previously it's true now. That is, if we look at x equals 1/2, we put that in there, 1/2 to the 23rd, it's still going to be above the x-axis. On the other side, if we have negative 1/2, we can take negative 1/2 to the 23rd, and while it'll be negative, it'll be below the y-axis. So the only point that actually ends up on the x-axis is the point when x is 0. And if you put in 0, you get 0. So 0, 0 is the only point. Again, how would I describe what's happening to the curve with respect to the x-axis to a second grader? I would say it was passing through the x-axis. Okay, so those are our two basic behaviors. Those are our what happens because of the degree of our polynomial. An odd degree will go through, an even degree will just touch. That's going to be really important as we study general rational polynomials, rational functions, those kind of things. The next video we're going to discuss what happens when these polynomials are on the top of a rational function or rational polynomial, and what happens when these polynomials are on the bottom. Now, I did promise in the last video, and I've almost forgot, so let me pause this and give you an explanation of what a polynomial is. Well, a polynomial is going to look a lot like this. It's going to have y equals, and it's going to have a coefficient. A coefficient is just a number that's in front of a term. There's going to be a highest degree term. In this case, the highest degree is, this is the only term we've got. But let's just do a little quick example of, let's say, a fifth order polynomial. I'm just going to make up some numbers here. We're going to have 2x to the fifth minus 3x to the fourth plus 7x cubed plus 9x squared. Let's go with minus, well, let's just go minus x, and then plus, I don't know, let's keep it normal here, plus 1. Yeah, let's do that. Okay. So this is our polynomial. It's kind of a coincidence that I'm going through -1, -1. I just happened to pick some nice numbers. That wasn't supposed to happen. You notice I'm not going through 1, 1. So that was a total accident. In fact, it may actually not be going through -1, -1. It may just be close. So ignore that little coincidence if it is. What is this? Well, this is a fifth degree polynomial. It's got a number of terms. It has a fifth degree term or a fifth order term, fourth order term, third order term, second order term, first order term. Remember, we can think of this as x to the first. And it actually has what we would call a zeroth order term, because x to the 0 is 1. And I can always multiply by 1. Notice nothing changed here when I hit return. Basically, that is 1, and 1 times 1 is 1. It's the same as it was previously. So typically what I'm going to have for a polynomial is terms where there's a variable to some power. That power cannot be a decimal. For example, 2.5. It can't be negative, can't be -2, for example. It has to be what we would call a whole number. So what's a whole number? A whole number is the counting numbers, 1, 2, 3, 4, 5, with the 0 added to it. So basically, whole numbers are 0, 1, 2, 3, 4, 5, so on down the line, 6, 7, 8, 9, all the way up to whatever you want to stop at. So this is the shape of a polynomial. Polynomial will generally have some number out front, and even if it doesn't, it still does. For example, what's out front of this term? Well, there's a 1 and a negative sign. So actually, the coefficient here would be considered -1. The coefficient here would be considered -3. Here, 2, 7, 9, and the coefficient here would just be a 1. This is also sometimes just called a constant. The constant term is sometimes called constant. This term is sometimes called a linear term. This is quadratic term, a cubic term. There's names for these too, but a lot of times we'll just start going fourth order, fifth order, so on down the line. Now these numbers, for example, the 2, doesn't have to be a 2. It can be 2.5, which is not a whole number. This is still a polynomial. It could be the square root of 2. Actually, let me just do pi because that's a little easier to get at. I can put in a pi. And by the way, notice that this point's no longer going through. But this is still a polynomial. So it doesn't matter what the coefficients are. It matters what the exponents are. As long as the exponents are whole numbers, this is a polynomial. So that's what we're studying. A linear polynomial would be something that just has these two terms. A quadratic polynomial would be something that has these three terms. And a cubic would have these. Now, some of the coefficients could be 0. That's not, except for the leading one. So if I've got a cubic, the coefficients here can be 0, but that cannot be 0. So in that sense, then, when we were looking at y equals x to the n, those were polynomials of nth order or nth degree. All right. I think that kind of covers it. So we're going to talk about polynomials. We're actually not going to talk about them in this sort of ugly form. We're going to talk about them in a much nicer form, a form that will be binomial in nature. We might also add quadratics. That's the most we will do, and I'll explain some of that the next time. But that's it for today's video. We went over quite a lot of material here as far as the polynomials are concerned, and we have a basic understanding that this particular animal shows us whether it passes through the x-axis at a 0 or just touches by the even or oddness of the degree of the polynomial. So that's it for this video. Let's go to the final screen. Whoops, I jumped a little too quick there. This has been A Tutoring Enterprises. We've been studying graphing of polynomial functions, specifically degrees and zeros of polynomial functions. Let's go ahead and take a quick look at my little advertisement for my tutoring business. My name is Joe Maciars, and I have a website at www.2tent.com. Please feel free to check it out. I have hours, my scheduled hours, and the prices, and all kinds of good information on there. I do online and in-person tutoring in physics, math, chemistry, and engineering. All right, let's move over. Nobody's ever liked me like you do. Yeah, please like the like button down below. Minimally that. I'm putting in some effort here for you, so like me. Okay, thank you. All right, if you feel like commenting too, that'd be great. If you really found this useful, go ahead and just send $1 or $2 to my PayPal account and help me get more technology. The more technology I get, the more I can help you guys, and the more great videos I can put out. I just recently got a video camera, which I'm hoping you're going to get a chance to see me doing some writing and talking about some of these subjects on paper, being able to do some things that I can't really do with this graphing calculator. But the graphing calculator has been a very useful thing. It's just that there's some things I just can't do. So look for that in the future. And let's move over to the white screen. And on the white screen, you should start seeing some links coming up to past videos and future videos, and perhaps some videos, some video series of other types that I'm doing, diversifying a little bit. So it may take a while to get some of those out there, but hopefully you'll see some of those. And other than that, I just want to thank you for watching this video, especially if you've made it to this point, and have a great day.